With this one, we're asked to find an expected value. And it says we're going to roll a die, and this is a six-sided die. Again, if we don't specify, then we're referring to a six-sided die, like a traditional one you'd use in any sort of a board game or anything. But you're going to roll a die and receive $1 for every point that shows. Okay, so if, in other words, the expected value is going to be $1 for every single number that rolls on the die. So if you roll a 3, that means you get $3. If you roll a 6, that means you get $6. So we need to figure out what the probability is for rolling a die. How many different options do we have? Okay, so we get $1 if we rolled a 1. Well, what's the probability we're going to roll a 1? The probability we're going to roll a 1, let's see, there are 6 sides to a die, so the probability would be 1/6. So our estimated value would be 1 times 1/6 plus, now if we roll a 2, and then we need to calculate the probability of rolling a 2. Rolling a 2 would also be 1/6. That's one side on the die has a 2 out of 6 total sides. So we can add that to it. This 2 here is $2. That is the $1 if we roll a 1, $2 if we roll a 2, and these are always 1/6 because the probability doesn't change for any of these. The next one would be 3. We'd get $3 if we rolled a 3, and the probability of getting a 3 would be 1/6. Again, and so we're going to do that all the way down the line. 4, 5, and 6 will all still basically be the same here. And you can just plug them into your calculator just like this. That will work just perfect. If you wanted to actually do all of the math on it, it would come out to a fraction which is 21/6. And 21/6 is the same thing as 3.5. So our expected value on this is 3.5. If you are, this helps whenever you're trying to set up games. You can expect what your average payout is going to be. Every time someone rolls it, you're roughly plan on about $3.50 every time someone rolls that die that you're going to end up paying out. It's really what that one's talking about. But the way we calculate that is $1 for every point. So if we have a 1, that would be $1, and the probability is 1/6. If we rolled a 4, that's $4. The probability would be 1/6. And then we're just going to add up every one of those. There are 6 sides to a die, so that's why I have 6 up here. And then we just simplify it, and we find out that our estimated value would be 3.5. Our payout is what essentially we're talking about, but the estimated value is 3.5.